Los Baños. He has a postdoctorate degree in protein chemistry from Korea Food Research Institute, Songnam City, South Korea. Earned his Doctor of Agriculture major in food science at Kyushu University in Fukuoka City, Japan. Earned his master's degree in agricultural engineering and bachelor's degree in sugar technology at the University of the Philippines, Los Baños. He authored and co-authored 8 book chapters and 86 referred publications. He is also a co-patent holder of the nucleotide sequences for the detection of salmonella and the detection process and kit issued by the Intellectual Property Office, Bureau of Patents. He also attended numerous notable research conferences, seminars, and trainings here and abroad, serving as oral paper presenter, poster paper presenter, and a resource speaker. He received various awards and distinctions. Some of these recent awards and distinctions, to name a few, are as follows. Outstanding Microbiologist in 2016 by the Philippine Society for Microbiology Incorporated, Outstanding Research Award in the Natural Science discipline, Senior Faculty category by the UP Los Baños in 2019, and as UP Scientist 1 from 2013 to 2015, and UP Scientist 2 from 2016 to 2018 and 2019 to 2021. He is also a member and officer of different academic organizations, including the Philippine Society for Microbiology Incorporated, wherein he served as the president from 2009 to 2010. He is also the former president of the Philippine Society for Lactic Acid Bacteria from 2013 to 2017, a regular member of the National Research Council of the Philippines, and the auditor of the Asian Federation of the Societies for Lactic Acid Bacteria at present, 2022 to 2023. Friends, ladies and gentlemen, a prolific speaker on food microbiology and biotechnology to discuss his study on entitled From Sugar Processing, Fermentation Technology, Microbiology to Nanotechnology, Nanobiotechnology, a Career of Non-Stopping Retooling. Let us give a virtual round of applause to Dr. Francisco B. Alegado.
Thank you, Jun Lee, for your kind introduction. Can everyone hear me?
Yes, sir.
Okay. So, Morena Aldos and Tugabos, good morning, fellow PSM members, guests, and participants. First of all, I would like to congratulate PSM Bicol, headed by Professor Marilu Barcela, and PSM National, headed by Dr. Lona May de la Cruz Papa, for continuously holding these activities in spite of the pandemic. We have more than 300 participants. Wow. Thank you for having me, and let me share my screen first. I hope you can see my screen now.
Yes, sir.
Okay, so it is my pleasure again to be with you in this convention. I think this is my 4th time as one of your speakers in several. You've been holding your convention almost yearly. So, well, in reference to your theme for this year, challenges and opportunities, microbiology and biotechnology, Bicolano experience. Well, I'd somewhat be delivering self-biography, if you may, as I'm asking for your kind indulgence. My hometown is the beautiful town of Irusim, located at the center of Sorsogon province. And I had a happy childhood, was educated in a public elementary school and a private Catholic high school. So one of my happiest moments in life was when I passed the UPCAT and scholarships at UPLB. Well, as many of you, I think, do experience, the first 2 years in our college life is kind of serious study. But then after that, joining student organizations would take a lot of our time and effort. In UPLB, you've got the February fairs and many organizational activities. And they were really enjoyable, more than that of microbiome and organic chemistry. And then that time, joining rallies, especially during those activism years, and against Marcelo, we've seen them as important to our life, and it kind of molded our life. However, in God's grace, I was able to finish BS Sugar Technology and was offered to work either in a sugar factory named Hawaiian Philippines Company in Silay, Negros. It's operated by Jardine Davis, newly formed, multinational company then. Then also the Biotech UPLB also was kind of recruiting me. And well, finally, I decided to work at Biotech upon the encouragement of an elder member of my academic workmate, Phil Justek, because he was saying there would be a prospect of pursuing graduate studies. So my first job was a research assistant, shared by two project leaders then. I was asked to implement research on ethanol fermentation from sugarcane molasses using immobilized yeast. And maybe you see this in that picture. I was kind of looking like Little Lapi then. Sorry, while monitoring laboratory research. And in the middle, maybe you can see us immobilizing yeast in the pilot plant together with my colleagues. It's kind of very hot day during that time. Sorry, nakaubad kami. So while working, some of us research assistants at Biotech were allowed to study part-time at reduced fee. And you're lucky today, you have got a lot of university scholarships being offered. But way back then, there were not many scholarships. And we really had to sweat it out studying part-time. Uh, it was counted really. We have to study during the weekends and work overtime past 5. So God's grades, I was able to finish MS Engineering, major in agricultural processing. And that time also I was doing research on alcohol fermentation, but this time using raw starch as substrate and fungi to saccharify or ferment the microorganism. Then a 1-year training opportunity came up when I was selected to participate in one of a UNESCO international postgraduate course in microbiology and biotechnology at IC Biotech, Osaka University. Many of our colleagues in PSM also had that kind of training. It was a 2-month lecture by notable Japanese professors and all over Japan, and a 10-month research in Kyushu University for my case. So it was an opportunity to be introduced to a Japanese professor willing to accept me for a doctor's degree. So first I applied for a Monbushi scholarship upon returning, hoping to do both MS and PhD in Japan. That would be a total for 6 years, but I was not lucky at first. So I decided to finish my MS in UPLB and then started to take PhD units, food science at UPLB. But again, I applied and through the embassy. So I was fortunate this time. I was accepted by the language course. It was really enjoyable, and so there were also other training or tooling opportunities that came up, such as the postdoc research at Korea Food Research Institute, where I studied the biochemistry of bacteriocin. And then 6 weeks training in advanced biotechnology, basically in fermentation technology in Germany, and then also training on the seed library construction, gene expression at the Asian Molecular Biology Organization sponsored training at Mishima, Japan, at the National Institute of Genetics, and also several collaborative research with GSPs. So many of those retooling opportunities helped me a lot in pursuing my future research projects, which I'll be briefly presenting in the succeeding slides. First, I'll be presenting 2 research projects on fermentation technology. So this was more than 10 years ago. Involves production of ethanol using high cell density yeast. So at least the one that I've learned in Germany, I was able to apply. So high cell density would increase productivity by shortening fermentation time, increase the yield and also productivity. And then, so uh, in alcohol fermentation, characteristic of yeast to be flocculating would be, applicable for cell recycling, known as the Mel-Boino process. We also worked a little on Simomonas at that time. So this first project embarked on yeast isolation from several sources. And for new isolates, our target was the flocculating ability, were isolated compared to the commercial strain 2030. You will see in here that those four isolates have really good flocculating ability. So we also screen them for other characteristics like acid tolerance, because for cell recycling, you need to wash them with acid to remove the contaminants. So finally, we decided to select one isolate, TB3. You will see in here that even at 10 to the fifth cells per ml retained at pH 2.5. So it was kind of ideal. So this is an important property. And so isolate TB3 was selected, and we tried for sugarcane juice and sweet sorghum juice fermentation. And you will see in here that the yield is kind of, I think, highest, no, compared to the other strains, even compared to the commercially used strains in the distilleries. So for juice and sweet sorghum, ethanol efficiency was quite high, and for sweet sorghum, the ethanol yield was very high, more than 11%. And in here, you will see that it grows comparatively better than the commercial strain. You will see in this, in the green, yellow green graph in here, that it has a very high cell population, and the ethanol also was comparable, even better than the commercially available strain, and it was very very fast, so consuming very fast the sugar. So we also tried increasing the temperature, and then we were glad to see that it has also have some good heat tolerance. In green, you will see that it produces a higher ethanol concentration compared at the ambient temperature, 30 degrees centigrade, even better than even if it was kind of sterilized. No? So you'll see in this, the TB3 was a good isolate. Okay, so we did repeated batch fermentation. After that, trying to kind of emulate cell recycling technology. So it was cell reuse. First, because it's flocculating, we kind of let it settle down to concentrate the yeast, and then remove the beer or the broth on top, and then added another feed. And the cycle went on, and we did it for several times. So this one you will see in here, repeated batch fermentation. And after more than 10, around 10, but I think we can still extend it, but we only did the experiment up to 10 times. And in here, productivity really increased a lot. You'll see in this graph, in this table, from that graph, that after 10 repeated batch fermentation, the time of fermentation was shortened to 13 hours, and productivity was also increasing. It was highest at around 7.26 gram per liter per hour. So ordinary ethanol fermentation can have only productivity of around 1.5 batch fermentation, 1.5 grams per liter per hour. So it really increased that much, and the final ethanol concentration was more than 16% by volume. Hence, we dubbed this strain super yeast. So it was ideal for industrial ethanol application, like high ethanol yield, high fermentation efficiency, faster fermentation time, and then high ethanol tolerance. It can tolerate up to more than 16%. Osmotolerance, because we're able to use a high sugar concentration of to 25%. And has remarkable flocculating ability, perfect for biomass separation and cell reuse. And again, it also had some tolerance to elevated temperatures up to 40 degrees centigrade. And there's acid tolerance. It's an important property. Well, right now, one ethanol distillery, how far is alcohol, is kind of using in a Palit Pampanga, using this isolate of us. And they have adopted the cell recycling technology. And we do collaborative work with them, and we hope to continue helping more alcohol distillery. Then we had this project. We implemented titled Optimization of Saccharification, Fermentation, and Purification for pilot scale ethanol production from lignocellulosic material. As you all know, the lignocellulosic materials would be the, I think, a future for ethanol production, because biomass is abundant, but there's a difficulty of producing ethanol from there, because you need to do pre-treatment because of the lignin content, and then the silan, no? So the silan or xylose is not utilized by ordinary yeast. So we used three kinds of feedstocks: sugarcane bagasse, sweet sorghum bagasse, and pineapple waste. And so this is the method that we've used. So this flow chart shows to us sample preparation and pre-treatment conditions. No, so we did a particle size reduction up to 0.5 millimeter, and then pre-treatment were done. For the sugarcane bagasse, we incorporated alkali impregnation prior to steam explosion pre-treatment. So because it has the highest lignin content, but for the sweet sorghum bagasse and pineapple husk or pineapple waste, we just did steam explosion pre-treatment. And after optimization by the previous project by Dr. Naibea, we use these parameters. So for our project, we did the optimization experiments using enzymatic saccharification. And uh, we did the drying, because in that case we can increase the substrate concentration or the substrate loading, and we kind of also optimize those substrate loading and an enzyme loading. You'll see in here the parameters used using central composite design or response surface methodology. And the temperature was fixed at 50 degrees centigrade, it's 4.8. And so the response was reducing sugar analyzed by the DNS method. And then we did data analysis and model development using the StatEase design expert software, and validated the experiments to compare the predicted response to the observed response. And the next slide would show to us that indeed increasing the substrate loading is critical in increasing sugars during saccharification of lignocellulose material. So for source for the three substrate really proportional to the enzyme loading, as well as the incubation time, and then also uh, uh, substrate loading. So the more enzymes you've got, the more substrate you've got, and the longer the incubation, the higher would be your reducing sugar. It's kind of expected, and we obtain for flask saccharification around 148.65 grams per liter. This is around 14.9% sugar, which is kind of good enough to pursue ethanol fermentation. And for sweet sorghum bagasse, you'll see in here that it was more than 10%, 106.5 grams per liter. And again, the conditions would be almost the maximum of those parameters. And also for pineapple husk, it's more than 10%. But for pilot scale use, we have to implement this saccharification reactor, which was designed in our project, and then we let it be fabricated by a local supplier. And the use of this one, as you will notice, no, saccharification was very efficient using this saccharification reactor. You can also control the temperature, and then also uh, hasten the process. And indeed, using the saccharification reactor, we were able to increase the sugar concentration from around 15% to more than 20% for sugarcane bagasse. And also for sweet sorghum bagasse, we also able to obtain more than 13% or 132 grams per liter, increasing by more than 20% compared to the flask fermentation. And fermentation also was facilitated using detoxification. We used activated coconut charcoal, I think, to remove the toxin prior to fermentation. And you will see in here that the ethanol concentration was more than 5%. Uh, this is quite comparable to those being obtained by other researchers abroad. And in one of the study, we did per evaporation. I'll not be showing it anymore, but we were able to increase it to 9%. So a 9% ethanol from lignocellulose can now be easily be purified up to I think into the absolute. I mean that absolute, but the fuel ethanol using distillation. So we were happy with this result. Now let's as move to some researches that we did in regards to microbiology and molecular biology. Uh, in the food program where I belonged before, we focus on studying our indigenous lactic acid bacteria from the fermented foods, basically, and other sources. So from sugar, from I became alcoholic, and then now I turned sour. So we isolated this lab, screened them, characterized, identified, and kind of fingerprinted using phenotypic and genotypic method. And also we included our basic studies, characterization of the probiotic properties, screening for important metabolites, and also such as the bacteriocin, and also we also did some structural gene sequencing, and then optimization of the production for both the biomass and for the metabolite. And we did several application studies, food preservation, flavor properties, uh, the herbal lactic acid bacteria interaction for nutraceutical purposes, and then also formulation of these cultures using immobilization, spray drying. and then viability and many others. So you will see in here that we've got a lot of these traditional fermented food products. I also a lot in Bicol, in Ginobatan. I like the longanisa that they've got in there, and we have many fermented fish products in various parts in Bicol. So here's the list of the bacteria, beneficial ones that we were able to isolate and characterize, and many of them are pedicocci and lactobacilli. And so we shared that generously also granted us a project, and then we did studies, several studies on the isolation and screening, and then probiotic characterization, as you will see in this slides, and then also there we were able to implement a project on the production of starter culture and uh, using them for functional food production. Uh, Here you will see that we were able to optimize selected lactic acid bacteria using low cost medium formulation, locally available materials, and then the project also granted us low temperature spray dryer, which we use in the pilot plant for the production of the biomass, and also we optimize the bacteriocin production, increasing the bacteriocin by as much as four folds. Okay, so I was also able to be involved in a project in the development of nanobiosensor. And the story was that I was requested by a previous director, Dr. Rinaldo Iborra. He's now the CAR director, and to host a Filipina American as balik scientist from Michigan State University, who she's in her laboratory developing nanobiosensors for several applications. Kaya yun, nahawa na rin ako. I was not really thinking that I'll be able to do this kind of nanotechnology-based research. And I had the opportunity for a 3-month training at Michigan State University, funded by Basis Conversion and Development Authority through the OST. So these training grants are really coming from people's money, people's grant, so our taxes and so on. So I really have to kind of, out of this training, do something. So in this training, we learned how to functionalize magnetic nanoparticles, nanomaterials, use them to capture the pathogen of interest uh, by functionalizing or putting coating it with something so that it can separate the bacteria. And then also we studied on how to sense them electrochemically. In here you will see a small handheld potentiostat and a desk potentiostat to do the electrochemical sensing. And it was indeed kind of a combination of microbiology. So really have to do some microbiology for this study, even if it's nanotechnology and then perhaps molecular biology based. It's a combination of these several technologies. Here you will see the plates that I was used in the plate count, and then also when we did the transmission electron microscopy, there you will see the magnetic nanoparticle capturing the bacteria. In this case, it's Listeria. And there is an example of the Excel that I've been using to report. So the knowledge of this technology encourages us to do research projects to develop a DNA-based nanobiosensor to detect E. coli, salmonella from water, feed, farm produce. So it has the competitive advantage being more rapid, easy to use with high sensitivity and selectivity, and kind of prospect for being portable, or you can use it outside the laboratory. So the challenges of the markets would kind of be solved, no? Using this technology. So this is how the technology works. So two sets of DNA probes were designed to be very specific for the target DNA. And in here, you will see that the detector probe was functionalized or attached to the magnetic nanoparticle. And then the capture probes also specifically designed to be specific for the bacteria was also attached to a biotin. So the biotin was later on used to immobilization in the screen printed carbon electrode, so that this one you can wash it out, the other contaminants, and then purely you can detect it by electrochemical reader or potential.
Recording stopped.
And because it's so specific, there would be a hybridization, and then in a short while it will be hybridized and then separated using magnet because of the magnetic material. If you have a nanomaterial, it increases the property to be magnetized, and then washing was very efficient to remove the other contaminants. And then finally, you can measure quantitatively. So we were able to create or design
Recording in progress.
probes, the various probes for these various target microorganisms. We also did some listeria before, and then also we can add it in here. So also there should be some kind of modified protocol to quickly, uh, extract the DNA, and then using also nanoparticles to extract it from solid matrices. And there also we did in-house validation of this nanobiosensor. In fresh farm produce, the pathogenic E. coli also in water was validated in the laboratory, and also we were able to validate the salmonella in eggs. And then finally, our project was able to do independent laboratory validation for E. coli, and we found it really quite efficient and effective. In here, you will see that we used 50 strains of E. coli and then more than 30 strains of non-E. coli, so that we can test the inclusivity or exclusivity of the nanobiosensors. And we obtained good results comparable to PCR, and then also in terms of accuracy, it's almost 90% compared to around 86% for PCR. Hence, we should say that this has some promise, this nanobiosensor, and you will try to propose some kind of another project so that we can try to finally bring it into the market. You can compare it with the leading detection systems in here, and it has a really competitive advantage. It can be quantitative, and it's very rapid depending on the matrix or on the sample that you'll be using. For others, you need at least a day or more, but for this one, 2 to 5 hours would be enough. It has higher sensitivity, and what the portability is really promising. Okay, so well, this is slide that really I should have been sharing to you. But indeed, opportunities and challenges for microbiology and biotechnology research really is, you know, you can, in my opinion, I summarize it in here. So uh, the opportunities are in black, the challenges are in red. Well, this field, your field, it can cut across several fields of interest or research. As you have noticed, with nanobiotechnology, there's microbiology, biotechnology. And now, with medical purposes, as you will see, the development of the RNA vaccine and other development really involves skills in microbiology. So it's really needed, no? Microbiology and biotechnology in several fields. Now, for students, a lot of opportunities for scholarships. I have been handling the course in molecular biology and biotechnology, and all over the country. It's a very popular graduate course in UPLB. And again, also when UPLB decided to incorporate uh, biotechnology in agriculture, now they have the ag biotech uh, course. uh, this course has been very attractive to several students, and students really graduate of this course are very good, and then they have several opportunities for scholarship. And of course, microbiology, biotechnology is so much applicable to our real life problems in food safety, in medical field, in health, and many others. It's really, there's a lot of opportunity with the use of field. And finally, for those who have graduated,
One moment.
sorry, you've been looking for jobs. It's really easy. Microbiologists are really in demand, and uh, many industries are looking for them. Even some distilleries they are looking, and many there's increasing demand for microbiologists and biotechnology. But here are the challenges. The field is really rapidly evolving. Thus, there's always the need for retooling. You don't have to stick to what you previously know and then go on with that. No, may iwan tayo. So we really need to retool. Sorry. And also, another challenge was that for this kind of field, you need advanced equipment, expensive materials, molecular biology equipment, and many advanced equipment for research, which state universities SUs also should be able to obtain, so that the research and then the products they'd be developing would be kind of competitive, especially if you want to publish your research, your results, without the use of this equipment. Sometimes they would not, no, the reviewers would not anymore accept some papers. So it's a pity, but we really have to get this advanced equipment to have stable electricity para okay siya i-operate and so on. Now, of course, you need a lot of thorough knowledge of the field, trainings for the research skills, and for the practice of your field. And then this field is only for those that really have the patience. No? Kailangang matyaga talaga. It's laborious, time-consuming, and doing research is not that you can stop doing research. You are expected to spend a lot of time over time, and then maybe you can work. Especially if you do graduate studies abroad, you really have to work hard. So yan lang naisip ko mga challenges, and there would be still a lot of them, I guess. Okay, so this would be my last slide. All of this researches, all of this what I am now, I really owe a lot to my colleagues, students, and then also co-members in the society, the several societies that we've got, and then of course when we do some kind of field work, there's really it encourages us, and of course mentors. I have shown in here some of my mentors, and of course the private company. Yakult and I have very good relationship and kind of helping them. The people in the distilleries and many other industries really are kind of supporting us, and then we can also help them in a way. And of course, my family, my inspiration, of course, and above all, God Almighty for all this. Sorry about this, para akong nag-ano na, no? Stop na to. So this is my last slide. Thank you very much for your kind attention. I hope I
Right.
was on time.
Yes, sir.
Mamaya na.
Okay. Opo. So thank you very much, Dr. Elegado, for sharing the key points of your two studies. So we have the use of selected yeast in high cell density ethanol fermentation, and of course the pilot scale ethanol production, wherein saccharification fermentation process are optimized. So truly this field of interest is a career of non-stopping retooling. So as what Dr. Eligado said kanina, we need to retool because this field of interest nga is rapidly evolving. So again, thank you also, sir, for sharing with us the tips on how we can overcome the challenges in microbiology and biotechnology. So truly the talk was informative and interesting. So if you have any questions and clarifications for Dr. Elegado, you may reserve them during the open forum later, or you may already keep your questions coming in the chat so that our working committee members could summarize them. So to continue, our second speaker is Dr. Albert Remus R. Rosana. He is a sessional science instructor at Grant McEwan University, Edmonton City, Alberta in Canada from June 2014 to present. He also served as microbiologist in the laboratory of Dr. David S. Wishart at the University of Alberta from March to December 2015. Prior to this, he also became a research assistant and laboratory manager in various laboratories and served as a teaching assistant in the same institution. From August 2009 to March 2010, he served as technical production supervisor, microbiologist of Vantarian Private Limited in Singapore, and from October 2007 to March 2010, as the molecular microbiologist of Interactive Microorganisms Laboratories Private Limited, also in Singapore. He was once a university instructor too at the University of the Philippines, Los Baños, from January 2006 to May 2007. He earned his Doctor of Philosophy in Chemistry in chemical biology in 2001, his master's degree in microbiology and biotechnology in 2013, both at the University of Alberta in Edmonton City, Alberta, Canada. He graduated his bachelor's degree in biology at the University of the Philippines, Los Baños, last 2005 as magna cum laude and the valedictorian of his batch. He is also a member of the board of editor for microbiology of the Journal of Nature Studies from 2020 to 2022, a reviewer of prestigious publications such as Applied Biology, International Microbiology, Philippine Journal of Sciences, and the Philippine Science Letters, to name a few. He is also a reviewer for Biotechnology and Biological Sciences Research Council, United Kingdom in 2020, and Czech Science Foundation, Czech Republic in 2020. He received several awards and honors, including the Dorothy J. Killiam Memorial Graduate Prize and Isaac Walton Killiam Memorial Scholarship